Assalamu alaikum. Following the series on Physics 9702, in this video we are going to discuss some past paper questions from particle physics in line with the marking scheme that is shared by Cambridge. So the very first question we have is from October-November 23. It says the result of the alpha particle scattering experiment led to the development of the nuclear model for the atom. State the results that suggested that most of the mass of atom is concentrated in a very small region and most of the atom is empty space. Now, what most of you had done was first you had rewritten the entire statement, दोनों points, there was no need for you to do so. It had already been mentioned. उन्होंने आपसे पूछा कि ये दो फाइनल आउटकम्स थे, ये दो फाइनल रिजल्ट्स थे, आप हमें बताएं कि एक्सपेरिमेंटल आउटकम क्या था जिसके बेसिस पे हमने इन दो रिजल्ट्स को डिराइव किया था. So the two main points that are under discussion here are, first, that the mass is concentrated in a very small region, and then the second one is that most of the atom is empty. We had discussed that in alpha particle scattering experiment, we had seen that most of the alpha particles passed undeflected. That was the outcome which led to the result that फिर यकीनन most of the atom would be empty. So you would mention that most of the alpha particles passed undeflected, suggesting that most of the atom is empty. That is where we had answered one point. And then the next we have is that the mass of atom is concentrated in its center. ये हमने final result जो है वो quote किया था on the basis that there were very few of alpha particles which were deflected at an angle greater than 90 degree. So फिर हमने कहा था they must have encountered the nucleus, and since ये जो reflect back कर रहे हैं जो greater than 90 degree एंगल पर जो हैं वो डेविएट हो रहे हैं, फिर यकीनन दीज आर द वंस जिन्होंने न्यूक्लियस को एनकाउंटर किया है. एंड क्योंकि इसका रेशो बहुत कम है, सो दिस मेड अस कंक्लूड कि यकीनन फिर जो मास ऑफ न्यूक्लियस है, it is जो mass of atom है, it is concentrated in a very small region that we later on termed as nucleus. So for that you would mention that very few alpha particles were deflected at an angle greater than 90 degree, suggesting that most of the mass of atom is concentrated in a very small region. Then they are asking for stating the composition of gamma radiation, as we had already discussed. जैसे ही आप alpha particle का नाम सुने, the very first thing that should come to your mind is helium nucleus. जैसे ही आप बीटा पार्टिकल का नाम सुने, the very first thing that should come to your mind is fast moving electron. And as soon as you hear about gamma radiation, the very first thing that should come to your mind is they are electromagnetic radiations or waves. And then of course had they asked the same question for like 2 to 3 marks, उसके बाद फिर मैं जाती कि this is how gamma is represented, it moves at the speed of light and that it has no mass, it has no charge, it is unaffected by electric field or magnetic field, so on and so forth. Then they are asking कि this table lists the name of three particles and their possible classification, and आपने tick place करना है in the boxes to indicate the classification that apply to each particle. पहले तो इन्होंने जो हमें क्लासिफिकेशन दिए थे गिवन दीज इन टर्म्स ऑफ बारियंस hadrons एंड leptons. तो सबसे पहले तो वी शुड बी वेरी क्लियर अबाउट ये तीनों क्या होते थे, राइट? So we had studied that there are particles जो strong nuclear force को experience करते हैं. These are hadrons, right? And then there are the ones जो strong nuclear force को experience नहीं करते. These are the fundamental particles जिनको हम leptons का नाम देते हैं. And fundamentals में we had already studied electron is a fundamental particle, and being its antiparticle, positron is also a fundamental particle. Neutrino, electron, antineutrino, they are all fundamental particles. So they all fall into the category of leptons. But when it comes to hadrons was not that simplified. Isko we had further classified into baryons and mesons. And then we said that baryons are the ones which are made up of three quarks, and mesons are the ones which are made up of one quark and one antiquark, right? Now, why did I have to mention all these things here? This is just for you to be very clear that a hadron can either be a baryon or a meson. But if a particle already falls into the category of baryon, it has to be a hadron, right? So a particle which is hadron can or cannot be a baryon, but a particle which already is a baryon, it has to fall in the category of hadrons as well, right? So this makes us conclude that अगर मैं कह रही हूँ कि किसी भी particle के आगे मैं अगर baryon के लिए tick करती हूँ तो it has to be hadron as well, right? That was the very common mistake that you had made in the very last test. When it comes to neutrino, it is a lepton. When it comes to positron, it is a lepton. And the examiner had assigned 1 mark for the student who identified it clearly कि neutrino and positron, they are leptons. And then the other mark was assigned if a student had clearly placed neutron as a baryon, which is a hadron. Now the very next question we have is, the very next part we have is, the discovery of a particle with an unusual charge was an important step in the development of the theory of quarks. The particle is a hadron with a mass of 2.19 exponent minus 27 kg and a charge of plus 2e, where e is the elementary charge. Calculate the mass in U of the particle. Give your answer to three significant figures. So we are already told that the mass of particle in kgs is 2.19 10 raised to the power minus 27, and we are asked to convert this mass into atomic mass unit, that is U, which represents the mass of nucleon. So in order to find the answer in the terms of U, all we have to know is what is the conversion factor from kilogram to U. And we know that if we have a value of mass in kilograms, we have to divide it with 1.66 10 raised to the power minus 27 in order to convert it into atomic mass unit. So given that we had a value 2.19 exponent minus 27, we had to divide it with 1.66 exponent minus 27, and we'd get the final answer in atomic mass units. This would give us 1.319, which we can round it off to 1.32. Then determine a possible quark composition of a hadron with a charge of plus 2e, and you have to explain your reasoning as well. As soon as you see this word hadron here, you should know that we are speaking of a particle that is made up of, so we know that it is made up of two or more quarks, right? If we are speaking of baryons, it has to be three quarks, and for mesons, it has to be two quarks. But what is important to write here is we have to identify a combination which gives us resultant charge of plus 2e, right? So in order to answer this question, quark K flavors should be on our fingertips, right? We know that we have up quark with plus 2 by 3 charge. The same is the case with charm and top. They also have charge equivalent to this. And then we have down quark minus 1 by 3. Then we have strange minus 1 by 3e. And then we have bottom, that is also minus 1 by 3e. So we have to make a combination of 2 or 3 which gives us plus 2 by e. The best possible combination here is, or I should be saying the only possible combination here is plus 2 by 3e plus 2 by 3e plus 2 by 3e, which gives us 6 by 3 elementary charge, which is nothing but 2 times the elementary charge. Now we have to explain the reasoning. That is the breakdown we had presented here. Now had they asked you कि आप वो मुझे लेबल करके बताओ, ये नेम करके बताओ वो पॉसिबल कॉम्बिनेशन क्या होगा, तो इट वुड हैव बीन अप टू यू बिकॉज इन तीनों का चार्ट सेम है ना. सो वी कैन ईदर मेंशन 3 up or maybe 3 charm or maybe 3 top, या फिर मैं इनका मिक्स एंड मैच करके कोई भी कॉम्बिनेशन बना देती. लेट्स से आई वुड हैव सेड up, top and charm, or maybe 2 up and 1 top, or maybe 1 up and 2 charm, so on and so forth. Multiple combinations are possible, and therefore in quark से related जितने भी questions आते हैं उसमें they had provided with multiple answers, and they had mentioned कि कोई भी combination that satisfies so and so condition would be acceptable. Then the next question we have is, in the following list, underline all the particles that are not fundamental, yani the ones that are not leptons or the ones which are hadrons. Baryon is a hadron, and nucleon, because इसके अंदर proton भी आता है and neutron भी आता है, they are also not fundamental. Positron and antineutrino, they are fundamental particles, so we have to underline the ones which are not fundamental. So we did. Then they are saying that a nucleus of thorium decays in stages by emitting alpha particles and beta particles to form a nucleus of lead, and determine the total number of alpha particles and the total number of beta particles that are emitted during the sequence of decays that form the nucleus of lead from the nucleus of thorium. Now, one thing you can do is you can do this mental math, and uske basis pe bhi you can find out the final answer, which I'm sure a few of these students will be very good at. But in order to ensure that we are following the right steps and that we can apply the same logic for any sort of equation they have provided us with, it is very important, and that is why I'd suggest you to always follow the equation that we are about to make here. They've said we had thorium, charge 90, mass 230, and it decayed to give a daughter element, lead, charge 82, mass 206, and with that certain number of alpha particles were emitted and a certain number of beta particles were also emitted. So as per the given scenario, this is the nuclear equation, right? And it is understood that a nuclear equation has to be conserved in terms of charge. That is, all these values should sum to 0. And in terms of mass as well, right and left sides pe they should equal. So what we are going to do next is, मुझे पता है for the conservation 230 should equal 206 plus n times 4 plus n times 0. Using this equation, we can rewrite, and this would then tell us that the difference would be 24, which divided by 4 would give us 6. That is, the value of n is 6, and n was nothing but the number of alpha particles. So now we know that total of 6 alpha particles were emitted during this decay. Now, number of alpha particles तो मुझे पता चल गया. How about number of beta particles? Again, you would go with the conservation इस equation की. And now we are going to apply the same concept on charge number, the one we did on mass number. So on left side we have 90, on right side we have 82 plus n into 2 plus capital N into minus 1. And this capital N, by the way, is going to represent the number of beta particles. So we had 90 minus 82, and we had already calculated the value of this n, which is 6. So 6 into 2 is going to give us 12, which when shifted to the other side is going to become minus 12, and this gives us minus 1. So we take the difference. 90 minus 82 is going to give us 8. 8 minus 12 is going to give us minus 4, which equals minus n. This suggests that n is equals to 4. That is, along with 6 alpha particles, 4 beta particles will emit. Then they are saying a meson has a charge of minus 1e. See, as soon as you see the word meson written here, आपके दिमाग में पहली बात आनी चाहिए. First, they experience a strong nuclear force. Second, they are hadrons. And the third thing should be they are made up of one quark and one antiquark, right? So they are saying that this has a charge of minus 1e, and e is the elementary charge, of course. The quark composition of meson includes a charm antiquark. So antiquark के बारे में they had already given us an information that it is charm. And then आपसे कह रहे हैं कि आप antiquark आपको पता चल गया. Now you have to identify the quark. उसका फ्लेवर कौन सा है जो इस charm antiquark के साथ मिलकर आपको resultant charge minus 1 ही करे. So we know that resultant charge is minus 1e, and we know that it is a meson, so it is made up of two quarks, एक quark and दूसरा antiquark. Antiquark they had mentioned charm, and हमें पता है charm quark का जो अपना charge है it is plus 2/3. So for charm antiquark, that is C bar, it should be minus 2/3. तो ये मैंने antiquark mention कर दिया. Then there is going to be a quark which so far I do not know the flavor of, so I am going to stick with simply Q, right? We are going to rewrite the equation. Minus 1e, this goes there, and it becomes plus 2/3e. And simplifying this equation, you get minus 1/3e. Now, मुझे ये पता लगाना था कि वो जो क्वार्क है यहाँ पर उसका फ्लेवर कौन सा है. सो मैंने पता लगाया कि यहाँ पर जो क्वार्क है उस पर चार्ज कौन सा बन रहा है. सो दैट दिस in addition to the charm anti-quark gives us a resultant charge of minus 1e. So now that we know that this is the charge that is on the supposed quark जो यहाँ पर इस composition में use हो रहा है. So अब ये charge जिस भी quark से correspond करता है मैं उसे यहाँ पर मेंशन कर देती हूँ. एंड द सेम वुड बी रिफ्लेक्टेड इन योर मार्क स्कीम एज वेल, बिकॉज मुझे पता है क्वार्ट्स में तीन तीन का चार्ज सेम होता है. जैसे minus 1/3 is the charge on down quark, it's the charge on strange quark, and it's the charge on up quark. So minus 1/3 is the charge on down quark, it's the charge on down quark, and it's the charge on up quark. So this is the charge on down quark, it's the charge on strange quark, and it's the charge on up quark. So it's the charge on bottom quark. So I can mention anyone here. I can mention that this meson is made up of down quark and anti-charm, going with this combination. Or I can say it is made up of a strange quark and anti-charm. Or I can say it is made up of bottom quark and anti-charm. तीनों combinations में I'd get the final charge that is -1e. So this is how we are going to answer this question here. And then we have one of the easiest questions the examiner could have asked, and they had asked this question. It says a lepton is an example of a fundamental particle that we had agreed, right? And they do not experience a strong nuclear force. Now, state what is meant by a fundamental particle. You'd think that you have to write something very logical, something very scientific here. But if you have a look at the mark scheme, you'd see that this is the most basic thing you could have written here. And the examiner is accepting this as a final response, as a valid response. So a fundamental particle is any particle that cannot be broken down or that is not made up of any other particle. Then a lambda particle is a hadron. As soon as you see hadron, I'm going to repeat it as many times as I have to. Hadrons are the ones which experience a strong nuclear force. It is categorized into baryons, which are made up of 3 quarks, and then mesons, which are made up of 1 quark and 1 antiquark. Now they are saying that this lambda is a hadron. It consists of 1 up quark, 1 down quark and 1 strange quark. अब आप मुझे बताएं कि इस lambda particle पर charge 0 है, you have to show it. And having solved a few of the past papers, we already know that जहां पर भी examiner हमें question में कहते हैं you have to show something, final result के marks नहीं होते. The marks are assigned to get to that result because result तो वो already आपको बता चुके हैं ना कि ये आएगा. सो यहाँ पर मेथड के मार्क्स हमें असाइन होते हैं. तो इन्होंने ऑलरेडी बता दिया इट कंसिस्ट ऑफ 1 अप क्वार्क के लिए द चार्ज इज +2/3e and down quark it is -1/3e, and then we have a strange quark. Strange is also -1/3e. So given that इन्होंने मुझे flavors बताए उसके हिसाब से I should be in a position to um, write their associated charges, and then जब मैं उन तीनों का resultant निकालूं तो मेरे पास answer 0 आना चाहिए. That is precisely what is going to happen here. +2/3e for up quark, then for down, and then we have for strange quark, and you simplify it, you'd get +2 minus 2 over 3, which is nothing but 0. Then they are saying that this lambda particle is unstable. It can decay into neutron and a pion as shown by the equation. The pion particle consists of an up quark and an up anti-quark. Like as soon as you see कि it is made up of up quark and an up anti-quark. जैसे आपने देखा कि it is not fundamental, it is made up of quarks, combination of quarks. आप कहेंगे इसका मतलब है कि जिस पार्टिकल की हम बात कर रहे हैं पायन की, इट इज नॉट अ लेप्टॉन, फंडामेंटल नहीं है ये, इट इज अ hadron. And hadron maybe is it baryon or meson? See, it is made up of 1 quark and 1 antiquark, so it falls into the category of mesons. Now they are asking you to compare the properties of an up quark and an up antiquark. किसी का भी जो एंटी काउंटर पार्ट है इसे हम एंटी मैटर कहते हैं, right? And the examiner is accepting this response no matter how simple you think it be. Up quark has a charge of +2/3e and up anti-quark has a charge of exact opposite, -2/3e. So the very first point that we can write here is they have equal charge. And then in another point, it would also be acceptable if you would write that they have opposite charge. I would prefer going with equal and opposite charge as one sentence. But just so you know, this is how examiner is accepting it. Like even if you write the charge being equal in magnitude in one point and you write it opposite in being nature in the other point, it would still be considered for 2 marks. And if you'd want to go with they have equal and opposite charge as point one, then for the next point you could write that they have equal mass, because matter or particle and its antiparticle, they always have equal mass. Otherwise you can mention that they are mesons, because इन्होंने कंपेयर करने को कहा है, so similarities भी हो सकती हैं इसमें and differences भी हो सकते हैं. They didn't say कि differentiate करें. So yes, you can mention that one is a matter and the other one is the antiparticle of it. You can say that they are not fundamental particles and they are mesons. Then explain why the neutron is classed as a baryon. Remember baryon made up of three quarks. And pion particle is classed as meson. Pion की composition इन्होंने already ऊपर बता दी ना. It was made up of one quark and one anti-quark. And meson तो होता ही वो है जो एक quark और एक anti-quark से मिलकर बनता है. So this is exactly what you are going to write here. आप यहाँ पर कहेंगे कि neutron is composed of three quarks and therefore is classified as a baryon. However, a pion particle, on the other hand, is composed of one quark and one antiquark, which classifies it as a meson. While answering questions from particle physics, sometimes you'd feel like that maybe I'm writing something wrong because this is so basic. But that is the case with particle physics. It's so basic, and yet so many students are penalized just because they do not pay attention to the command word, they do not pay attention to the category of particle that is mentioned. Then in the next and last question from this video, a stationary nucleus P of mass 243 decays by emitting an alpha particle of mass 4u, because alpha particle has 4 nucleons, right? And u represents the mass of one nucleon. Form a different nucleus Q. Yani this P was a parent nuclei. After decay, it emitted an alpha particle, and then we had a daughter nuclei, which is this Q. And they are saying that initial velocity of alpha particle. Now, do not get confused with the word initial here. Before the decay, the alpha particle did not even exist. तो मैं डिके के बाद जो अल्फा पार्टिकल की वेलोसिटी है मैं उसको फाइनल वेलोसिटी नहीं कह सकती, बिकॉज इससे पहले तो अल्फा पार्टिकल एग्जिस्ट ही नहीं था कर रहा, राइट? सो दिस इनिशियल is used for after decay. Then use the principle of conservation of momentum to explain why the initial velocity of nucleus Q and the alpha particle must be in opposite direction. Now what you had done, which I don't know for what reason, you decided to quote the exact same sentence that after the collision, as per the conservation of momentum, the velocity of alpha particle and that of Q would be in opposite direction. Yes, that's precisely what the examiner said would be the case. You were to justify it using the conservation of momentum. And that is what we are going to do here right now. See, before the collision, they didn't say that the nucleus P was moving with a certain velocity. And since it was the only body in the system before collision, and this was not moving at all, that means velocity was zero. This makes us conclude that momentum before decay was zero. In this case, there is no collision, so avoid using word collision. In this case, we can go with the word event, and that event is decay. Before decay and after decay. So momentum before decay, momentum ko, as you all know, we represent with capital P, right? So momentum before decay is nothing but the momentum of particle P, which is zero. The conservation of momentum suggests that momentum after decay should also be zero. And now after decay, we do not have one single body in the system. Now we have two bodies in the system. So the momentum after decay will be the sum of momentum of both the bodies, which is momentum of Q and momentum of alpha particle. And the conservation principle says momentum before decay was zero, so the total momentum after decay should also be zero. And this then suggests that income momentum should be in opposite direction, right? They should be opposite. And mass तो क्योंकि हमेशा positive होता है, so this situation is only possible if they have opposite velocities. Avoid using the word equal and opposite velocities. No, they have difference in their masses. So of course there is going to be a difference in their velocities as well. We are not going to comment on its velocity right now, not in terms of magnitude, but yes, in terms of uh, the sign, they'd be opposite, because of course alpha particle has comparatively lesser mass, so it has to have comparatively greater velocity to give equal momentum as that of particle Q, which has much greater mass than that of alpha particle. So how are you going to phrase it? You would mention that momentum before collision is zero, and you are going to mention that this PP is zero. In order to conserve momentum, or as per the law of conservation of momentum, the momentum after decay, not collision, and then you can mention in the bracket that this one should equal zero, and hence the velocities of Q and alpha should be opposite. That's it. You cannot write following the law of conservation of momentum, the velocities are going to be opposite. Yes, that is the case, but यहाँ पे 1 mark is assigned for you to first identify that the momentum before collision was zero, and so the momentum after, not collision, the momentum before decay was zero, so the momentum after decay should also equal zero. 1 mark for this, and then the other to identify it is only possible if the velocities are in opposite directions. Then determine the initial speed of nucleus Q. How do we find the initial speed of nucleus Q? They have provided us with, now we have agreed, right? Initial is after decay because that is when they were created, right? The velocity of alpha particle is 1.6 exponent 7. Q is 239. Okay. The initial speed of Q चाहिए. इसके लिए we are going to use the concept जो अभी हमने ऊपर equation बनाई थी, that the final momentum is zero, which is the sum of momentum of Q and momentum of alpha. Momentum of Q would be mass of Q times velocity of Q. And this velocity of Q is what we have to calculate. Mass of Q in terms of atomic mass unit is given to be 239 U. Then momentum of alpha is going to be mass of alpha times velocity of alpha. Mass of alpha is 4u. We are going to place the relative mass in terms of nucleons. And the velocity of alpha is given to be 1.6 exponent 7. This should give us 0. Okay. So what we can do is, do not worry about this u here, because this would eventually get cancelled. 4 into 1.6 exponent 7 into u, these gets cancelled, and now we are left with only one unknown, जिसकी value you can easily find out by multiplying 4 with 1.6 exponent 7 and then dividing it with 239. And since we had agreed कि इनकी velocity are going to be in opposite direction, so if you are going to call this positive, it has to be negative, which eventually balances this negative, and you would get the final answer. This gives us 2.7 exponent 5 meters per second. And now you have to calculate kinetic energy in mega electron volts of alpha particle. Now, the most, I would say, silly mistake you had done was you decided to go with the velocity you had calculated in the earlier part and आप उससे kinetic energy निकाल रहे हो. पहली गलती जो बच्चा कर रहा है वो ये कर रहा है, they had already mentioned that you have to find the kinetic energy of alpha particle, right? So kinetic energy of alpha would equal half mass of alpha particles times velocity of alpha particles squared. Now this half remains as it is. एक गलती आप ये कर रहे हैं कि आप velocity alpha की रखने के बजाय आप इस Q nucleus की रख रहे हैं. Alpha was 1.6 exponent 7. That is what you were supposed to place, right? दूसरी गलती जो आप कर रहे हैं वो आप वैल्यू प्लेस कर रहे हैं अल्फा पार्टिकल के मास की जगह 4. नो, दिस 4 वाज इन टर्म्स ऑफ मास ऑफ न्यूक्लियन. हालांकि किनेटिक एनर्जी का फाइनल आंसर जूल्स में आता है तब जब आप मास को किलोग्राम में और स्पीड को मीटर्स पर सेकंड में प्लेस करो. So you cannot just place 4u. You have to place 4 into 1.6 10 raised to the power minus 27. That is what we do now. Whenever we have to convert U into kilograms, what we do is we multiply it with 1.66 exponent minus 27, which is equivalent to 1U, right? So this factor right here was missing. This would give us answer around 8.5, 10 raised to the power minus 13 joules. But that is not even where you were supposed to stop. They asked you to find the final energy in terms of mega electron volt. So you are still left with one final conversion that we had already discussed, that whenever we have to convert joule into electron volt, we multiply the value in joule. Sorry, we divide the value in joule with charge of electron, that is 1.6 exponent minus 19. But still there is one point that you'd be missing even if you do ye wale step. Like, they didn't ask you to convert joule into electron volt. They asked you to convert joule into mega electron volt. So you can go with either approach. पहले आप जूल को इलेक्ट्रॉन वोल्ट में कन्वर्ट कर लें एंड देन आप उसको डिवाइड करें 10 रेज टू द पावर प्लस 6 से टू कन्वर्ट इट इनटू मेगा इलेक्ट्रॉन वोल्ट्स, या जो डायरेक्ट आप फैक्टर इसके अंदर अप्लाई कर सकते हो, इट वुड हैव बीन कि आपके पास जो जूल में वैल्यू है उसको you divide with 1.6 exponent minus 13. Minus 19 की जगह you went with minus 13 to compensate for this plus 6. And you would directly get your final answer in mega electron volt. So like यहाँ पर ये जो आपके पास joules में final answer था, आप इसको divide करते with 1.6 exponent minus 13 and आपके पास final answer आ जाता in mega electron volts, which is 5.3. if I had not mistaken. You can check for yourself as well. So I hope it made sense to you. I still stand by the point I made that this particle physics is a piece of cake, but that is not the case with the the mark scheme of A levels. That for sure is not a piece of cake. So you have to be very, very careful with answering the question. Concept, however, I would say is as easy as it can be. So till our next video, which I plan on making on the past paper questions from DC circuits and electricity. Allah Hafiz.